Hello everyone, how are you all? Today we are going to continue our discussion on projectile motion. In the last video, we have discussed projectile motion as projectile motion as two-dimensional motion. We have discussed projectile motion as two-dimensional motion, and in order to represent this two-dimensional plane, we have used horizontal axis and vertical axis. We call horizontal axis as x-axis and vertical axis as y-axis. After that, we have derived an expression for trajectory of motion. We have derived an equation for trajectory of motion. We have derived equation for trajectory means the path of a projectile, the path of the projectile. Then we derived an equation for time of flight. Time of flight, we represented it with a capital T, and capital T is equal to 2u sine theta by g, which we got in the last discussion, and we solved a very simple question: what are the factors on which the time period depends? If you have seen the video properly, for the derivation of these components, for the derivation of these equations, I have considered only one axis at one time, either vertical axis or horizontal axis, but one axis at one time. You might have got a doubt that is it correct when the motion is two-dimensional? Is it correct to consider only one dimension at one time? Are the two dimensions or the two axes the component of two axes? Component means, I mean to say, displacement, velocity, acceleration along a certain axis. So these, when I say components of an axis, components of y-axis, I mean that displacement along y-axis, velocity along y-axis, acceleration along y-axis. And when I say horizontal components, I mean the displacement along horizontal axis, that is x-axis, velocity along x-axis, and acceleration along x-axis. So are the components of the vertical and horizontal axis are independent to each other? So let me put some light on this, whether they are really independent or not. For that, I am taking here two case studies. Okay, and to make you understand, I have recruited a friend of mine. Okay, so let's do the case studies. First, case study number 1. Our intention is to see whether the vertical components and the horizontal components are really dependent or independent of each other. So that is our intention to do this case study. So let's see our case study 1. In case study 1, what I am doing is, I am asking one of my friend, okay, I am asking one of my friend to go to the top of a multi-story building. Okay, to go to the top of a multi-story building and stand there. So this is my friend, our friend. So he is going to do the activities for us. He is going to do activities for us. I haven't named him anything. If you have any suggestion, please write it in the comment section, because he is going to be very useful for us. All the activities, experiments will be done by our friend. So see that our friend, I have asked him to go to the top of a multi-story building. Okay, so he went there. I gave him 2 balls. I gave him 2 iron balls. I have given him 2 iron balls. First, I told him to drop the ball, drop one ball. First, I told him to drop one ball. So he dropped this black ball. Okay, he dropped this black ball. So when the black ball was dropped, what? See here, the motion, the black ball is dropped. It will fall downwards. Right? It will fall downwards. So this, which axis is this? This is vertical axis. So which axis is this? Vertical axis. So what is the initial velocity when he dropped the ball? The initial velocity, I am representing it by uy, is equal to 0. And since what is the acceleration along this axis? Acceleration is ay, which is equal to acceleration due to gravity, and that is taking place because of gravitational pull. So gradually the velocity is going to increase as the body moves down. Clear? Let us assume that this height from which is dropping is of height h. Is of height h. And I have told him also to measure the time taken for the body to reach the ground, and he said that the time is capital T. The height from which he is thrown it is capital H, and the time taken to reach the ground is capital T. I have told him to measure the time also. Now see here, initial velocity is 0, acceleration is g. So what is the velocity at any time? Vy, velocity at any time. How can I write it? Uy minus, let me do one thing, let me write little bit side. Okay. So what is the velocity here? Vy at any time, velocity at any time. Vy is equal to uy plus at, correct? At any time t. So here in this case it is going to be Vy, uy is 0, you have dropped it. When you drop it, the initial velocity is 0. 0 plus a is g along y-axis g, and time is any time t. So this is the expression for velocity at any time. Say this point, you have to measure the time into g will give the velocity at this point. Next, what is the distance? Distance covered by it. So distance covered by the body along y-axis, let's call the displacement along the y-axis as y, is equal to uxt plus half at square. Uxt plus half at square. And here in this condition, y is going to be ux is 0, 0 into t, 0. Half ay is g t square. So this is the displacement of the body at any time t. At any time t. Clear? Next, what is the other equation? Vy square is equal to uy square plus 2ay, correct? So here also in this condition, Vy square equal to uy 0, 0 square 0, 2a is minus, a is g, so 2gy. So this is the third equation. So I am writing the equations of motion for our body which is dropped downward. So I have measured time also. Time it is t is equal to time is capital T to cover the distance h. Clear? So what is the relation of time with respect to h? How to find out? I can find it from this equation, right? So if I write t square equal to 2y by g, so t is equal to under root of 2y by g for the total distance h. So t will become total time of flight, capital T is equal to 2h by g. So this is the expression. This is the expression we have got. So please remember these things which I have written in the boxes. Okay, let's just see, let's call it as 4. So one ball fell down, cover distance h or displacement h, time taken t. So one ball is over. Now he has another ball in his hand. I have asked him to throw the ball with the initial velocity horizontally equal to ux. So when he is throwing, there is no vertical component for this. There is only horizontal component, and I have said to him to throw it with the velocity ux in a horizontal direction. Now, if you see what is the motion of the body, so body is going to move like this. The body is going to move like this, right? And it is going to fall here. It is going to fall here. Now again, I have told him to find the time. You might have think that this is less distance. This is more distance. So the time taken along this motion will be more compared to this. Correct? Do you think that now the time is greater than t? But if you really do this activity, you will find that even if there is a horizontal velocity and the body is covering a horizontal distance, even then the time taken to reach the ground still it is t. There is no change in time of flight, whether the horizontal velocity is present or not. Clear? Let me explain with the help of these equations. See that. First, when the body is, I have thrown it in this direction. See that there is an iron ball, and the air is not going to affect. Iron ball is having enough weight so that the air is not going to affect the motion. That's why I have taken these iron balls. And see that. So what is the acceleration acting on the body at any point of time? It is equal to g, that too, suppose here g downward, suppose here g downward, suppose here g downward, and that g is always constant. The g is always constant in a constant direction, uniform acceleration. And what is the velocity? What is the initial velocity? Along y-axis? Vy is equal to 0. Earlier also 0, now also 0. What is the acceleration in vertical axis? G. So initial velocity is same, acceleration also same. So are they not? See that? Are they not going to give the equations for this also? Can't I say that even the horizontal component present or not, vertical components are going to give me the same result? See, vertically it will cover how much height? Vertically, height h. So, I can conclude here that the vertical components are independent of horizontal components. Clear? Now, one more important thing. When I told my friend to do this activity, I have also told him to find the distance, horizontal distance covered. I am calling it as x. I have told him to find the horizontal distance covered, and this horizontal distance is equal to ux into t. This is equal to ux into t. See that it was thrown by velocity ux horizontally, so velocity into time, that means what? No acceleration along the horizontal axis. Point number 1. And number 2, this displacement is not at all dependent upon any vertical component. This displacement is not at all dependent upon vertical component. That means what? Not only vertical components are independent, but also horizontal components are independent of vertical components. That means if you do any if you do analysis in any one component along in any one component means either along vertical axis or horizontal axis, the result is not going to change. I hope it's clear. So here, by seeing all this, what you can say? You can say that horizontal components and vertical components are independent of each other, or you can consider this two-dimensional motion. See there, this it is moving in the plane x and y. This two-dimensional motion, you can consider it as two one-dimensional motions. So do the analysis of any one dimension which is required given in the question. Enough. That is enough. Okay. I hope you have understood. Let me give you another case study. Okay. Let me give you another case study. This time, I have asked my friend to bring a car. Okay. This time I have asked my friend to bring a car. So he brought his car. Wheels of car. Okay, sports car. He brought sports car. He's sitting inside. Okay. Now again I gave him one iron ball. So I told him throw the iron ball vertically upward with velocity uy. So here thrown with the velocity uy, it went up to a certain height h. Let's consider this as height h. Right? So it went up to a certain height h and again returned back to his hand. Correct? And the time of flight for going to the topmost point and again returning back is capital T. So I asked him, when you throw it with velocity uy vertically upward, please note down the height as well as the time period, and he has noted that down. Now what did I say? You see that? I asked him to So I have asked him one thing. So I have asked him to drive to point A. I have asked him to drive until point A. So this is point A for us. And there is a point B here. So this is point B. So all are the same vehicles. Okay, I cannot draw all identical. So please pardon for that. Right? So this is the point B. There is the point B. Do you know what is the distance between A and B? I have okay. Let me explain you the condition, then I will tell what's the distance between A and B. So what I said is, I asked my friend to drive the vehicle with velocity ux, right? So when he reached point A, with velocity ux at point A, I have started by time, and when the time is equal to capital T, when the time is equal to capital T, my friend has reached the position B. That means if you travel with ux, a constant velocity ux, then you will reach B in time capital T. Okay, so the distance whichever covered by our friend, that is represented by x because it is along the x-axis or horizontal axis. X is equal to nothing but ux into t because our friend is driving with constant speed, constant velocity. Is driving with constant velocity. So displacement is equal to ux into t. Clear? Now I said to my friend, take this iron ball. Take this iron ball. When you reach A, then throw the iron ball vertically upward. Remember, I'm saying him to throw it vertically upward. It is equal to, with the velocity equal to uy, the earlier velocity uy. I have asked him to throw it upward. Right? So he did that. He was driving, he was coming with the velocity ux. When he reached A, suddenly he has thrown it upward with velocity uy. See, our friend is very precise. Whatever we say, he does. So if you suggest some name for him, we'll use it. Okay. So as soon as he reaches A, he throws it vertically upward and vertically upward with uy, and when the ball came to his hand back, okay, the ball went up and it came back. So when the ball came right back at his hand downward, he found himself at position B. Our friend threw the ball when he reached A vertically upward with velocity uv, and the ball went up, and again it returned back to his hand. But when he saw his position, he is at B. If we see it from the ground, if we people see it from ground, what is the motion of the ball? The motion of the ball would seem like this. The motion of the ball would seem like this. Right? Same time, same velocity moved upward, and it reached back with the time t, with the time of flight capital T. But this time he started his position. He is not constant at a given position. He started at A. He reached B. How is this possible? How is this possible? He has thrown the ball upward, and when the ball reaches down, by that time the ball as well as the whole body is at B. How is this possible? So let us understand this, how this is possible. See that he is moving with constant speed ux, right? So the vehicle is moving with constant speed ux. Inside the body, our friend is there. He is also moving with the ux. And the ball which he is holding is also traveling with the ux. So when he has thrown up vertically, though he is throwing vertically upward, the ball itself possesses the velocity, horizontal velocity ux. So when he reaches the point B, see that, is this not the projectile motion? Is this not the projectile motion? That means if you throw vertically upward, the time taken to reach again with the speed uy is capital T. Here the time is also capital T when thrown with velocity uy. Clear? And if you clearly see this at the highest point, if you could measure it, this would be the same as height. I hope now you can understand that this horizontal component which I see, this is a two-dimensional, right? Horizontal, vertical, it's moving on the plane. This plane has a board plane. Body moving like this, right? Like this as well as this. But for doing analysis, if we take any one axis is enough. Our result is not going to change because these two axes are independent to each other. They are not affecting each other. They are not affecting each other. Clear? So doing analysis along one axis is correct. Doing analysis at one axis is correct. Right? Moreover, it makes our analysis simple because at one point what we have to do? Only consider one axis. Clear? Now let's come to the question. Today's question. Okay. Today's question is the range of projectile depends upon A. Angle of projection, B. Acceleration due to gravity, C. Mass of projectile, D. Magnitude of velocity of projectile. Now I will suggest that if you haven't seen the past video, that is the last video, first part of this, if you haven't seen that, I request you now to see the video, and after seeing the video, come again to this time and solve the question. Clear? So what is that? Projectile, right? Axis, vertical axis Vx, horizontal axis thrown with ux, thrown with the velocity u. So it has two components, horizontal component ux, u cos theta, vertical component u sin theta. Now how does our body move? Our body moves in a projectile. Our body moves in a projectile. Clear? Body moves in a projectile. So this is let me write this as Vx. So Vx is always constant. Vx is always constant equal to u cos theta. Now what he is asking? He is asking range. Range means what? Horizontal distance covered by the body. Horizontal distance covered by the body. I am represented by capital R. So this distance, you see, how to find this distance? This distance or displacement, you can say. How to find that? Since our body is moving with constant speed along the horizontal direction, just to consider horizontal direction for now. Vertical direction is not important. Vertical components are not important. One dimension is enough. That is the horizontal dimension. If the velocity is constant, then the displacement. How to write the displacement? U cos theta. Horizontal velocity Vx into time taken. What is the time taken? See here. And from starting point to the point when it again reaches the ground, what is that time? That time is nothing but time of flight. Clear? The velocity into time of flight. Now see, now look at here. What is Vx? Vx equal to u cos theta. What is t from the last video? 2u sin theta by g. 2u sin theta by g. Now see here. Let me write u square 2 sin theta cos theta excuse me by g. So u square 2 sin theta cos theta is sin 2 theta. Okay, this is a trigonometric identity. 2 sin theta cos theta is equal to sin 2 theta divided by g. So range R is dependent upon what are the factors? Number one, let's see. Let's answer the question. The first question, first option, angle of projection. And where is the angle of projection? Theta. Yes, first one is correct. Acceleration due to gravity. G. Yes, second one correct. Mass of projectile. Any mass component here? No. The third one is wrong. Fourth, the magnitude of velocity. See that? U square. Yes. So the answer is A, B and D. The answer is A, B and D. Let's see how they are related to each other and how to get this maximum distance. How to get the maximum distance? I am calling it as a range of maximum range. So how to get that? So to get maximum range, I have two options. Can I change G? No. So I have two options. Either I can increase U or I have to throw with separate a particular angle theta so that the r will become maximum. So more the value of u, the more is the value of r. More is the value of u, more is the value of u square. Hence, more is the value of range. So if u is fixed, hence what you have, for example, I can give an example here. Suppose you have a cannonball. Okay, you have a cannon here. Okay, so cannon is this is a cannon which is rested upon wheels. I think it will be rested upon wheels. Okay, two wheels. So when you fire a ball from this, the velocity of the ball is fixed, but what you can change the angle. In the same way, if u is fixed, the velocity with which it is thrown is fixed, then what you can do, you can use the angle, that is change the angle. So at what angle this value will be maximum? At what angle that value is going to be maximum? Let's check. U is fixed, right? U is fixed. At what angle that is going to be maximum? So sine 2 theta will be maximum at what? What is the maximum value of sine 2 theta? It is 1. So this is maximum only when our 2 theta is equal to 90 degree. Remember, sine 90 is 1. So 2 theta is equal to 90 degrees. So theta will be equal to 90 by 2, 45 degree. So what is the R max? U square by G. If a theta is equal to 45, this is the maximum value. When U is fixed. I hope that through today's discussion you have understood nicely. And if you have any doubt, please feel free to ask. Okay. Take care of yourself. Thank you.